Okay, in this part 1 video, we're looking at the differences between mass and weight. Okay, so the mental model that I have in my head is literally this. I picture an astronaut on the surface of the Earth, and then the same astronaut on the surface of the moon. Okay, it doesn't have to be an astronaut. It could be a bowling ball on the surface of the Earth, the same bowling ball on the surface of the moon. Okay, so here's the main idea. Mass is a measure of the amount of a substance. He talks about that more formally in the Hagen textbook. But let's say the astronaut weighs, we say weighs, but let's say the astronaut has a mass of 80 kilograms. Okay? This 80 kilograms is the same whether the astronaut's on the surface of the Earth or the surface of the moon. Okay, in an English units setup, the mass would be measured in slugs. Okay, that's the dimensionally consistent set of units for this formula, W equals m times g. Okay, so in both cases you can plug in the formulas if you know the gravitational constant of Earth. Okay, so for the metric system, we put that in the MKS or the SI standard units for that, and that would be 9.81 meters per second squared. That gets plugged in here for G, and mass gets plugged in here, and we get this value. Okay, the difference on the surface of the moon is that the gravitational constant is different. It's not as strong. The moon is not as big of a mass. Okay, and so the gravitational forces are less, so we plug G in as before, but the mass of the astronaut did not change. The physical amount of substance that makes up the mass of the astronaut is constant. So you plug those in and you get 130 newtons, a value that's less than what it was on Earth. Okay, and the final point to make is this can be done for both the Earth and the moon using the English units. Okay, but if you're going to use English units, the formula weight is equal to mass times gravity. That means the mass needs to be in slugs. Okay, we're going to move on to some other parts where we're going to explain the difference between using mass with the units of pound mass rather than slugs, because in my experience, it's more common to use pound mass than it is to use the English units of slug to represent mass. This is going to create some confusion, and so in the subsequent videos, hopefully we can cover that so you'll understand exactly what's going on.